When finding the parametrization of the lines in which two planes intersect, you want to begin by setting a variable to 0 or to any number in order to find the other two variables. So for example, in this question you have this plane and this plane. Let's set z to 0. So you have x plus 3y equals 4, and you have x plus 2y equals 2. Now you want to solve for one of the variables. I'm going to start off by solving for x, so I would use the process of elimination, which will give me x plus 3y equals 4 for the first one, and then negative x minus 2y equals negative 2 for the second one. Cross the x values out, I get y equals 4 minus 2, which gives me 2. Now that I have y, I am going to substitute this y over here into this y over here, or this one, whichever one you feel would be easiest. So for me, it's this one. So I would do x plus 3y, which is 2, equals 4, which gives me x plus 6 equals 4. Subtract 6 on both sides, I get x equals negative 2. Now this is my x values. And remember how we set our z to be 0? That would be our z value. So if you're going to write it, you'll have x equals negative 2, y equals 2, and z equals 0. Now we are saving this for later. Next step you want to do is you want to find the normal vectors for both planes. Normal vector is just vector in IJK form. So for, let's call this vector A and this vector B. Normal vector for vector A would be 1i plus 3j minus 6k. And for vector B, you would have 1i plus 2j minus 4k. After you get the normal vectors for both planes, you are going to find the cross product. So you do A cross B gives you IJK. For your A values, it's 1, 3, and negative 6. Your B values is 1, 2, negative 4. So now you want to find the determinant. So you do 1 for I, for J, and for K. Let me write these values for J. You would then do 1, negative 6, 1, and negative 4. 1, negative 6, 1, and negative 4. And for K, it would be 1, 3, 1, 2. 1, 3, 1, 2. Now you are going to evaluate. So negative 4 times 3 is negative 12, minus negative 6 times 2 is negative 12, minus J, negative 4 times 1 is negative 4, minus 6 times 1 is minus 6, plus, I forgot to write K here. K, 1 times 2 is 2, minus 3 times 1 is 3. So you get 0i minus 4 minus 6 is 2j plus 2 minus 3 is negative 1 minus 1k. So this is your normal vector of the two planes. Now, to find the parametrization of the line, you just want to plug the values of the normal vector and the point into the equation for parametrization. So you get x, y, and z. You equal that, and then x will equals to negative 2, y equals to 2, and z equals to 0. And then you are going to find the t values. The t values will just be the values of the normal vectors. So for x, it will be 0t. For y, it will be negative 2t. And for z, it will be negative 1t. So if you want to simplify that, you get x equals negative 2, y equals 2 minus 2t, and z equals negative 1t. And that is the parametrization of the line in which this plane and this plane intersect.